Hello, my name's Steve Bradby. I'm the engineering leader for Select Plant Hire in the UK. Select has a very ambitious innovation and sustainability target, and in order to achieve this, we work very closely and collaboratively with our suppliers. So what you're about to see is the T-Link telematics system which Select and Terex have been collaborating on for a number of years. Not only will you see how we're using it now, but you'll see how we intend to develop it in the future in order to provide something truly useful to our customers. What you're seeing is part of a much larger piece of work where we're obtaining feeds from multiple different pieces of plant to try and turn them into something that's really useful for customers and our sites. The aim is to give them true insights to help them improve efficiency, safety and sustainability. So the real difference we're seeing with the Terex telematics is the level of data it's providing. Most people, when they hear the word telematics, think of a piece of kit that's telling them when they're low on fuel, or if there's an error code, or if a piece of plant is idling for too long and maybe being driven too fast or something. But here we have true use data, something that can give real insights as to where the opportunities lie for the user. And to quote Zach Ramon from Insight, data is the new oil. So how does telematics become really useful to site? Well, it has to show the truth. We've got to be able to trust it. It has to be relevant and it has to be accurate. But it also needs to sit alongside the data that's generated from the BIM model, from the AI cameras, from time-lapse, from as-built surveys and drone data. Because all of that data combined tells the true story of where the site is against its program. So if we go into the system, we start with seeing a map. On the map, we can see which cranes are live and which cranes are inactive, and we can zoom in and select an individual crane. When we select the crane, we can see live data showing exactly what the crane's doing at that moment in time, but more on that in a minute. We can also, going back to the map, select the wind finder option, and we can see live weather data and forecast data for the week ahead, by the hour and specific to a location, so it can really assist with lift planning. If we select live data, we can see multiple cranes at the same time, either on the whole fleet or just by specific site, and see their live status. We have a replay function in which we can see exactly what the crane was doing over a selected period. Here I'm showing it at 10 times speed. You can even see each mechanism being used and the speed selected by the operator. And on the right hand side we can see exactly what was happening at the time. We can see the wind speed, the weight reading, the moment, the hook height, and the radius. We can also see the hour meter readings for each of the individual functions as well as the crane itself. There are a number of pre-designed reports, so here we have one showing the total amount of weight being lifted each day. The box at the top allows us to put in an amount to offset the weight of the lifting tackle and rope weight. We can also count the number of lifts in a day, and also the individual weights lifted, so here we even get the time for each lift. There's also an exceptionally complicated looking graph which actually has a phenomenal amount of data in it, and it really tells you what's going on at any moment in time. So on the bottom we can actually see the hook height in green, the weight in blue, and also the radius in grey. On the top graph we can see the slewing speed in purple and the wind speed in orange. So let's have a little look and see what we can gain out of this. So if you look in this area here, you can actually see the wind speed is high and the slewing speed is 0, and the crane's hook is actually at a medium height. And I think it's fair to say, especially bearing in mind that the wind speed is breaching the upper limit, that this crane was winded off at this point. So if we look here, we can see some weight increases and some hoist height changes. This is also the case on the previous day, where we can see some significant weights being lifted by the crane. This is matched on the top graph where we can see some changes in slewing. So we know the crane was being well used at these particular moments in time. We can also see in places where the crane was reaching out to full radius. And also we have an indicator of when the crane was slewing full speed in one direction or the other. So now we're starting to get an understanding of how well the crane's actually being used as the week goes on. In this case, not particularly well. So now let's have a look at the graph that shows how long the crane was switched on for, and then the times of operation of each individual mechanism. So here we're seeing the full story. The crane really isn't working very hard at all. Even if those mechanisms were used one at a time, the crane is actually idle for a lot of the day. So let's see what other conclusions we can draw. We have the ability to actually produce our own reports in the platform, so we can actually plot different things against each other. So let's look at how often the crane was using its maximum speeds, for example. So here we've plotted the winch speed on the top graph in green, the luffing speed in the middle graph in yellow, and on the bottom graph we've got the slewing speed. So where we see the peaks is where it's hitting its maximum gear, its maximum speed. Now, the real beauty is here, I can export this data into Excel, and then I can manipulate it and actually pick out how much time the crane spent in each gear. So here's the statistics. So in slewing, it only spent 150 seconds in total during the week in its maximum speed. In hoisting, 325 seconds. And luffing, 986 seconds. So let's say that the crane is too slow, because we often hear that accusation, your crane's too slow, so let's double the speed of a mechanism. So doubling the speed would gain us 8 minutes. 8 minutes. It's not a lot, is it? But 8 minutes, surely, that can make a real difference. Well, not really. When we look at this graph here, we can actually see the proper utilisation of the crane, and the crane sat for hours in between lifts. On the first day, half an hour out of a total of 7.82 hours the crane was working. On the second day, 0.67 out of 9 hours. So let's look at the analogy of Formula One. If your car's 1 mile an hour faster than everyone else, it's not going to make much difference. The place where all of the team spent their effort was on the pit stop. And now, we're seeing pit stops of 2 seconds. Why? Because if the pit stop takes half an hour, you're never going to win the race. You're never going to make up that time, no matter how much faster you go. And that's the reality of accusations such as Ukraine's too slow. People are looking in the wrong place. And I know this isn't a busy crane, but what type of crane is it? Well, it's a 630. It's a 32-ton luffing crane. It's a big crane, and it's on a major construction project. Now, admittedly, it is slowed down due to COVID at the moment, but even if we were to cram all those lifts into half a day, there would still be massive timings between each lift while we're waiting for the next load to be ready. So does speed really make a difference? Well, not really. But the one thing you can take is if you are going to improve the speed of the crane, in this example, would be the luffing mechanism, because that's the mechanism that sat at its maximum speed for the most amount of time. So it would make a difference, and that's where telematics can actually help influence crane design for the right reasons, because we're basing it on truth. It also maybe hints that the site's layout maybe isn't as good as it should, because if the crane's having to luff a lot, you're losing a lot of time to that mechanism. But in reality, there's other things and factors in there that can really help us determine how efficient the site is. And, taking all of this data and actually turning it into something useful is where we need to head. We've made this platform available to our sites. And yes, at first they have a look and they're very interested, but the interest soon drops off. They're too busy doing other things. What we really need to do is what the rest of industry does, which is show a KPI, something that's a real indicator, something that they can glance at and say, yes, my site's doing brilliantly, or no, I've got a real problem. So what we now need to do is use this data to generate that next step, to give those indicators that tell us whether the site's too congested, whether the cranes are so close together they're spending all their time in slowdown due to the anti-collision system, and whether the loading bay is just too far away from the offload point. We can get some really good data in here that can really educate our sites and really make a difference to how we plan and how we work. So that's our conclusion. That's the next step, to try and pull these together and then match them with other feeds such as the AI. That way, the crane becomes truly central to the productivity on site and can really help with the future. So thank you for listening. I hope that was thought-provoking. If you've got suggestions as to what you think KPIs should be, I'd be interested to hear them.